we have our panelist, Sergio Martins, Director of Air Traffic Management, Latin America, SAP Group. Before we start, we'd like to share with you, as usual, we have simultaneous interpretation. You may select the Spanish or English languages in the Zoom menu, where we have a symbol of the world. And if you do not want to hear the original audio, you may click on mute original audio. As you may remember from previous webinars, the chat function is disabled. If you want to ask a question to Sergio, you must send it to the email that you will see on screen, info@ACI-LAC-LAC.aero. We'll have Q&A at the end of the presentation, and now I would like to give the floor to Sergio. So good morning. Let me know if we see the screen. Yes, we see it. My name is Sergio Martins. I thank you so much, ACI, for the opportunity of talking to you about an issue that I have been studying for a very long time. I've started my professional work in the 80s as an air traffic controller in Rio de Janeiro airport. And it's been 41 years now, always involved in air traffic management in the Latin American region. I believe that it'd be necessary to establish a few commitments to carry out that webinar. Among them, we would include the fact that it'll be absolutely conceptual. What I want to do is to transmit concepts so that you in each state, airline, airport, and company may start to develop solutions that make sense technically and operationally. That means we'll leave it at the conceptual level only in an agnostic manner, meaning we won't prioritize any technology or model or concept, but rather we will present them all with precise information. It's not what I think, it's not what SAP thinks, it's the reality, the fact of the concepts to be inclusive, that it doesn't, we won't only be presenting chunks, pieces of the reality, but the whole surrounding, the balance of demand and capacity, which is something we really need in the region. And all of it supported by formal documentation from ACI Council, FAA, etc. We're not here to talk about what Sergio believes or what SAP believes, but to consolidate everything that has been published via formal mechanisms about this issue. And the agenda, we'll start talking about surface operations at the airport and airport surface operations. And then we'll talk about apron management and surveillance technologies, which are key for surface management. Then we'll talk about the concept of CDM, and we're talking about CDM without any letter before that, the concept. The concept of CDM proposed by OASI in document 9971 in 2012, and requirements and commitments you must understand before you start to play with the CDM operation. And then we will talk about the two operational concepts that have been developed throughout the world of air control with CDM and with the surface CDM. We'll talk about each with a conclusion at the end. Then we are talking about surface operations. We can say that the best practices that have been published by all the organizations, OASI, Council, FAA, RASA, are dedicated to promoting efficiency, safety, capacity, and predictability of the surface operations. If we're able to get these four elements aligned in the surface operations, we have reached a maximum performance of the airport. And it is key to understand that reaching the optimum performance of the airport ensures that we would have a minimum impact in the flight intentions of the airlines. And this is a key moment to understand two things. One, the effort made to increase the capacity, the performance of the operations of surface operations without touching on the intentions of the airlines, flight intentions of the airlines. And whatever it is, the demand overcomes the capacity. We'll see that clearly. Which are the best practices that historically OASI Council have recommended for surface operations? Let's talk about the apron management. We'll go to document 9137, the Airport Services Manual, Part 8, Section 10. It talks about apron management and apron safety. It's very clear that the air traffic control service is dedicated at promoting the safety of the operation in the area, maneuvering area, which is the but there are no specific instructions at the apron level. So it is necessary to have a apron management service to ensure that everything flows in a streamlined manner. All the aircrafts and vehicles are moving properly. The other paragraph says that the coordinated management, which is the way in which most airports operate in Latin America, a coordinated management between the radio control and the apron, there is communication with the pilot, radio control, while the airport is responsible for the vehicle. And in all the communications of the controller with the pilot, there is nothing but assuring the separation between aircrafts and vehicles, meaning there is no responsibility of the controller, flight controller, over the efficiency of and safety. It's under the responsibility really of the pilots and vehicle drivers and on land personnel. And this is key to understand. You can't expect for the air traffic controller, whose only commitment is to maintain the frequency with the pilots, to give them specially information that was made available by the airport operator, like position 8, for example. He can't handle more complex movements such as simultaneous movements, lanes, parallel lanes within the apron. It is not his responsibility to do that. Actually, if he tries to do that, then he would take away the attention from his primary obligation, which is that maneuverability area. If we go to this other document, 2020-1234, to talk about the apron management, it defines that the apron management service must ensure the efficient management of movement of aircrafts and vehicles within the platform. We are talking about initiatives to improve the efficiency, safety, predictability, and capacity within the platform of the airport. So it is clear that having an apron management dedicated apron management is recommended to optimize the surface operations performance. It is mandatory? No, it is not mandatory. Is it mandatory? No. But it is clear that this is a measure whose objective is to increase the efficiency, predictability, capacity, and safety of the operations within the platform. Now we can talk about the surveillance technologies. It's like saying, okay, let's try to demonstrate, show a blind person that he can walk better in a more efficient manner, quicker, if he can see. So, document 9830, the SM GCS manual, it is clear, Advanced Surface Movement Guidance and Control System, ACE-MIX. It is expected to provide adequate capacity and safety with regards to specific weather conditions, traffic density, and aerodrome layout, complexity using integration technologies and integration. It's clear the air traffic controller, when there are visibility conditions and there's more traffic and the operation becomes more complex, then you'll have more of a difficulty to predict dangerous incidents. When we see this is not the objective of the webinar, but when we see this platform, SMICS document 9830 of OASI, what it provides for is surveillance sensors. So OASI recommends surveillance sensors to increase the capacity and safety of the operation at the airport. And the OASI and their Global Air Navigation Plan, if we go to ASBU-SURF B02, it talks about the awareness, comprehensive situation awareness of surface operations. What it tells you is that the surveillance services must provide situational awareness through the position identification and tracking of aircraft and vehicles in the surface of the airport. And furthermore, this information shall be presented to the controller, air controller, flight controller, and airport operator. If we go beyond that to a more modern concept, to everyone who are part of the airport, which includes the airline, ground handlers, etc. And that's more or less, like I said at the beginning, we go from a blind operation to a situational awareness operation. And even if it's stated in OASI document, it's logical. If you can see, you have more of a capacity to offer efficiency, capacity, predictability, and safety in the operation. So it's clear that the use of surveillance technologies have always been recommended to generate what we call common situational awareness to optimize the surface operations performance. It is important, and as of now, we have not talked about CDM at all. We haven't mentioned any interference in the flight intentions of the airlines. We are only trying to increase the efficiency, the capacity, the safety, and the predictability of the surface operations. So for decades, the adoption of dedicated apron management and the use of surveillance technologies have been recommended to improve the performance capacity of surface operations. And this is an example, which is a master example, where we have a dedicated center for surveillance. This is an apron management center dedicated. There are surveillance mechanisms, not only the cooperational surveillance, but also the digital visualization. There's an accrual of surveillance technologies to ensure that the surface of the airport is used at its maximum capacity with efficiency and predictability. And there's a very short video of the operation of an apron management center using surface surveillance. You might not be able to hear the audio, but it's got the legend at the bottom. This is what we are talking about, an operation where there is a dedicated center to manage the apron area. And that way, with surveillance tools, they can manage parallel taxiways, simultaneous taxiways, etc. These are mechanisms that are not related with interfering in the flight intention of the airlines, but rather to increase the efficiency, capacity, predictability of the surface operation. This same airport, this is the airport, just for you to have an idea. This is the airport in Rio, and we have had this month the show of Madonna's show. It generated a huge accrual of traffic. See how busy it was. This is, you can see this is live. The airport has sent me this actually, because what happened is one airline moved temporarily to Rio to cover the demand from the singer Madonna show. So of course, this operation with a dedicated management service with the surface surveillance, which is not only visualizing the position, but everything is recorded. There are statistical calculations. There is a whole set of functionalities that go beyond just monitoring the movement of aircrafts and vehicles. As of now, we have not talked about interfering with the flight intentions of the airlines, right? Everything we have talked about is increasing the capacity of a physical infrastructure. And by doing a comparison with a city, it's like if we were trying to increase the capacity of the vehicle traffic, synchronizing the lights, traffic lights, and the streets to give more operational capacity to the specific infrastructure. But what happens is, even if you carry out all the efforts to increase the capacity of the physical infrastructure, the growth of traffic cannot be stopped. And to give you an example, it's impressive. When I started to work in 83, 41 years ago now, the worldwide population was 4 billion people. And the traffic at the biggest traffic airport was 25. 40 years afterwards, the worldwide population had doubled to become 8 billion, and the traffic in New York had jumped from 25 to 100 million passengers, 4 times as much. So what this clearly means that it's that the need and the desire to fly grows more and faster than the infrastructure of the airspace and of the airport. There's no way to stop that. And the only way would be to increase the price of the tickets to a level where people cannot fly. But organically, it is not feasible to increase the capacity of the airspace and of the infrastructure of the airport at the speed and dimension of the growth of the need and desire to fly by people. So what this means is, at some point, at this moment, will depend on the region, on the airport, on the state or status of development, many things. But at some point, the demand will exceed the maximum capacity. Even if we have done everything that OASI has recommended to increase the capacity, airspace, and airport, at some point, we will have to interfere in the flight intention of the airlines. Bad news, but it is necessary, or we will have to stop flying. And it is essential for people to understand that for this purpose, the concept of CDM operations has been designed. When people try to say CDM is cooperating and sharing information, fantastic. Cooperation and sharing information. It's essential in any human activity, any. Nevertheless, when we talk about CDM in air transportation, we are talking about interfering in the flight intentions of the airlines. Why? Because we have done everything possible within the airspace and the surfaces to increase the operational capacity. And at some point, the demand will surpass the capacity. What does the concept of CDM say? That is part of document 9971 of OASI. Well, it proposes something very serious, which is to balance the needs of all individuals. This is what CDM aims for in aviation, with a air traffic flow management, which uses measures to balance out capacity and demand in the airspace and in the airports. It's a single piece. The flight leaves from one airport, it flies in the airspace, and it reaches another airport. This set of elements has an maximum operational capacity, and at some point, some flight will exceed this capacity. So what the OASI proposes is that as of now, in that moment, when a flight will overcome the capacity, integrate the capacity, airspace, airport, it must be communicated by the flight operator while the aircraft is not flying, it's on land. This is very serious. Why? Because you have to tell the airline, hey, you cannot take off. Why? Because no matter what happens, it'll be stopped either in a queue waiting or in flight, in orbit, consuming fuel and necessarily generating CO2 and impacting on environment for no purpose at all. So this is when this program was founded, the ground delay program, to balance out the demand and the capacity. Does it delay flight? Yes, because the delay, the only thing that will change, it won't delay the arrival time. The arrival time will be delayed no matter what, but it'll avoid for the aircraft to be stopped, number 20, to take off in a queue of 40 minutes, in a 40-minute queue, or 30 minutes flying out in the air. Is it mandatory? No, but it is essential for people to understand that when you hear a CDM, what I'm looking for is to avoid interruptions. Without interruptions, leaving the gate, taxi, takeoff, flight, land, taxi, that like that. I mean, I don't know if it's cultural or what for whatever purpose, but I like to go out and wait, close the door and wait. Okay, you can keep operating that way, just waiting in line. But I mean, CDM, what it will do is cooperate and share information only. Of course not. We cannot dream that way. There are sacrifices from the individuals and in the collective for a long-term global achievement. To give you an idea of what this looks like, in normal conditions, the ideal scenario, the aircraft departs airport A, it arrives at airport B. Fantastic. But at some point, because the activity is so hectic, there's a restriction in the airspace airport set. There is a restriction of capacity, and this flight will have to stop at some point. It could be on land in waiting, on or in orbit, flying, pending, waiting for that problem to be solved, capacity problem to be solved. And this implies delays of the operation. What does CDM tell you? That you should avoid the delay, and if it happens, it should be done with engines off on land. So there is a sequencing done by the CDM on flight, so that for each flight you define an acceptable schedule of arrival of the flight to this point, where it can go through without interruptions, calculated time over. That way you reduce the time on flight from the flight plan, and it's the limitation of takeoff time restriction. This is informed to the airport so that at this time the flight can leave, and when it arrives to this congestion point, there are no capacity limitations. So on the one hand, I have to delay the flight, but on the other hand, we do the uninterrupted operation. This is CDM operation. Are there sacrifices? Always. That is why starting a CDM operation when I have not complied with all the stages recommended to increase the capacity is trying to adjust the demand to a capacity which has been underused. So this is the CDM operation with the flow management center sending the takeoff limitation or restrictions. From CANSO, we have a warning implementing air traffic flow management and collaborative decision making, meaning implementing a surveillance system that can monitor aircraft and vehicles. It significantly enhances the capacity of the airport and the predictability of the operation. Why? Because it is clear. I mean, if I'm trying to do a ground delay program sequencing flights based on the takeoff time, this takeoff time has to be absolutely precise. I mean, if it's estimated takeoff time of every day, okay, I'll just do the sequencing that would mean nothing. So in order for me to come into a CDM operation, I must have already developed extreme predictability in the operation on surface. And we have seen that which are the initiatives recommended to increase the efficiency, predictability, apron management, surface surveillance, like Hanso says. That's why we have always been against CDM attempts in the airport that operates in a blind fashion, without a dedicated operation with minimum predictability of the operation. As passengers, you get to the gate, you ask, what time is the flight coming? It'll in a while. Why? Because I heard that it landed. So in a while, 5, 10, 15 minutes, it'll be here. Hey, if I have no precision and the arrival time for the airport at the gate, how can I have a precise time forecasted for the exit from the gate? It's impossible. It would be impossible. Therefore, when we talk about CDM operations, again, we are talking about, without any letter before it, we're talking about specifically the CDM operation specifically. And I always tell people, don't try to learn anything from CDM if you don't start through the first page, which are the requirements and commitments of a CDM operation. So, requirement. I need operation of the surface which are highly predictable. Why? Because we will have sequencings, and if I have no forecasted hours very precisely, it won't work. I must comply doing the homework, implementing the initiatives that increase the efficiency, capacity, and predictability of the operation. And this is most critical in the commitment. Understanding that what the CDM operation proposes is to give the fuel efficiency higher priority than punctuality. This is fundamental. How many people have gone into CDM programs? They believe that won't affect their punctuality when it comes to closing the door. Of course it will, because the CDM operation, what it will do by default is to adapt the demand to the capacity, because you have exceeded the capacity and flights will be delayed when need be, so that they can be in operation without interruptions. And this must be clear. And this has been the origin of many misunderstandings and confusions in the region. People, when they realize they want to do something related to CDM and flights get delayed. Yes, of course. How can you expect, for example, a ground delayed program? It is called ground delay. This to delay flights. It's a stage one of a CDM program. It delays flights. And then you have to start to think, what is important? Is it punctuality or predictability? I mean, the passenger doesn't have a commitment with the chair of the aircraft. closing the door at the right time, it means nothing. If the passenger will spend 30 minutes sitting there, 40 minutes taxiway to leave the gate, and then 40 minutes in taxiway, we've created a culture with something that is not relevant. And whenever we are obsessed by this culture, there is no CDM because CDM is against that. Now, something key. How do we get to the CDM concepts in the airport environments? There have been two main initiatives. In Europe, as next step to an implementation of a CDM, the aircraft traffic flow and capacity management with a program that got to up to the CTODs, which are the calculated takeoff times and restrictions, takeoff time restrictions. Basically, in the United States, they have created the time-based flow management. Likewise, with a ground delay program that has led to the EDCT's expected departure clearance time. Again, it is a takeoff restriction time. So whenever you apply the concept of CDM operation provided for under this document 9971, what you'll have is takeoff time restrictions. It's not a collateral effect, but it is the essence of the concept that is proposed. Now, I'll ask you, what happens if I have a takeoff time restriction, but I am still approving the initiation of the operation by first call, first serve? So I have flights with takeoff time restrictions that cannot take off when they wanted to, but they're still being authorized by first come, first served at the beginning of the operation. Of course, this will generate congestion, which is unacceptable at the surface level. They will have to wait, say what, 10 minutes, and everyone behind them 10 minutes, and the other one 15, etc. So you've generated a level which is unacceptable of surface congestion. And this was clear in Europe and also in the United States, that what should be done is to sequence the initiation of the operation. If I started with the ground delay program, when by limiting the takeoff time, and this is multiplied, not only do I have one flight with a restriction takeoff time, but several flights with pilots are doing pushback and they get to the taxiway by order of first come, first served. This will be unacceptable, and it happened in Europe and the United States. The only difference is that in Europe, the initiation of the operation is the pushback and taxi, because they operate with the flight controller talking to the pilot, authorizing the pushback and taxi. In the US, the initiation of the operation is the access to the maneuvering area because the controller is not engaged there. So the standard way of operation US is the platform or apron congestion. The airport manages the flights within the apron area. So the initiation of the operation for the aircraft controller is not the pushback by the entry to the taxiway. So aero control and FAA did the same to sequence it out in totally different manners. Both concepts, airport CDM and surface CDM, they are very different. How does this work? If I have a precise estimate, I have an approval time, which is adequate, feasible. The pilot calls within an interval of tolerance, which is admissible to initiate the operation, pushback or entry at the maneuvering area in the US, clear to start. The operation starts. But what happens, I mean, if I have no predictability at the airport, I have an estimate that is not precise. It's whatever happens every day or the best I can do, because I have so many ground handlers that don't tell me what time they'll be cleaning, take food, etc. So it's not about coming up with the best estimate. It's about being precise. So it's not a feasible time when I call for the pushback or entry point into the maneuvering area. It's outside of the tolerance interval. And what it tells me is that to be in line with the CDM concept, okay, I must hold the position, present a new estimate to get a new approval time. So what was a delay, it was multiplied by one more delay because you'll go to the end of the queue. And this is what happens always when I try to come up with a model, an implementation of CDM concept under a low predictability level. I try to implement something which is too rigid when the calculations and the numbers that I have are not predictable. It's more or less as if we tried to use a calculator with a decimal boxes with whole numbers. It doesn't work. Both models, it's not, I mean, this could be an objective of another seminar. It's not the objective of this seminar, but to explain the differences, all the differences between airport CDMs of Eurocontrol, which is CDM, ACDM, and then FAA, which is the surface CDM. The Eurocontrol has developed a concept called 16 milestone approach, establishing a setup line, which is 3 hours before the exit time until the real time. And they have created a system of theory oriented. It's not good or bad, it's just the way they have created it. They have established that the airport operator should invest on a platform to share information with the assist, ACDM common sharing platform. That's why when you see the curve of the CDM investments in the first year, it's green. The airport is the only one that is on negative because the concept ACDM, Eurocontrol, provides for an investment of the airport in this platform. So what has FAA done? FAA, and this is documented, they visited Europe, they verified and studied the ACDM, and they said, we understand that concept. We have to restrict the individual flexibility to increase the global capacity. But to provide for our needs and the way we operate, they have created a concept of CDM at the airport, which is based on the visual display, meaning to visualize the surface of the airport, aircraft and vehicles with a top-down view, which is more or less the same OASI proposes in the ASBU B02, which says to share surveillance information of the surface level. The essence of this, of the surface CDM of FAA, is to share information of surface surveillance to then, with this, allow airlines and ground handlers to say exactly what time they would be ready. It's important to realize that the end objective, the airport CDM and the surface CDM, is the same, to reduce the individual flexibility to increase the global capacity. But they have gone in two different ways to reach the same objective. As a conclusion of all of this, what I want you to keep with you to take as a takeaway, as a content of this webinar, first, that airport operators should consider as on a priority basis the adoption of best practices recommended to optimize the surface operations performance. Meaning, there are very clear recommendations that are not related to CDM. They're not related with interfering with the flight intention of the airlines to increase the operational capacity of a physical infrastructure. And we have seen apron management, surface surveillance. These are the initiatives recommended to get better use of the physical infrastructure. The CDM operation concept has been developed to take care of big congestions of traffic. Why? Because it interferes with the flight intention of the airlines. And it requires more predictability, and it means airlines have to change their priorities, in terms of fuel efficiency and above as a priority above punctuality. So it is clear that trying to go through a CDM operation without having gone through the process of increasing the capacity, efficiency, predictability of the airport, it's like trying to stop the delaying the demand to adapt to an underused capacity. And even more, it has not generated the predictability that will be required to implement the CDM operation concept. Finally, the CDM are airport concepts. Eurocontrol and surface control of FAA were designed to promote the integration of the airport integration with systems and control programs to control the flow, which are collaborative. Existing 9971 in Europe, the airflow traffic and capacity management. In the US, time flow capacity management. These concepts have been designed to integrate these airports to these flow management systems, which are collaborative, which already existed. What it means is that you should not try to import any of them as if they were in a generic operations manual, because they ignore all the activities related to capacity increase, and they ignore all the priority changes that are established when you choose a CDM operation system. So, how many people have started with a CDM program without having this idea that at some point flights would be delayed because of this, because they thought that it was about operating and sharing information. Fantastic. We don't have to pay anything, right? Nothing, no pain. But these are the three golden rules of thumb that I would like you to take as a takeaway. Surely there will be questions and there will be needs, and I am here for you. Any other webinar that can concentrate on specific points of this issue, which is quite complex actually. And that's why I have this 360-degree vision. I started as an air traffic control. I have worked as a flight engineer and have worked in the airports. I'm in the industry in different companies for more than 30 years. So I have a 360-degree vision on how it all fits the airport universe with the airlines, with your aircraft and airspace world. That would be 45 minutes. I will give the floor back to ACI. Thank you so much, Sergio. Just to remind you, you can send your questions to this email that you see on your screen, info@aci-lac.aero. We'll share that with Sergio. We have one question, Sergio. Who is responsible for controlling the apron? Very good question. The reason why, this is why, when we use the word control, it's an error. The apron is not an area that can be controlled. There is no control service provided at the apron. The responsibility for what happens at the apron, by definition, belongs to the airport operator, the airport. But traditionally in Latin America, we have used the coordinated management, where the air controller talks to the pilots to transmit information that usually are provided by the airport operator, and they move around the vehicles transportation, etc. But the problem we have with this is that it's adapted to low level of traffic. But if we go to a more complex operation, we want to do simultaneous pushbacks, parallel taxi, you can't do it with the flight controller being like a manager, informal manager of the apron. So to answer your question, the apron is not controlled, it is managed. And the responsibility of the management is in the hands of the airport operator. We advise a dedicated management by the operator or by an airline also, the bigger airline in the airport, or third-party companies which are experts. What's key here is the fact that an airline would operate the apron the apron operations. It does not give them any advantage over the rest of the airlines. Why? Because the allocations of the positions are in the hands of the airport, and the sequences are not in their hands either. So it only improves the flow of the traffic, the safety, the capacity, the predictability. It does not generate anything else, and that's why it's so common. In the United States, for example, many airlines manage several terminals where there are no flights of their own companies. They just provide the dedicated, efficient management service. That way, the air traffic controller is released from that responsibility. Another question, which technologies do you refer to when you suggest surveillance technologies? Traditionally, when the ACE-MIX concept was developed, we talked about primary and secondary surveillance, non-corporational and corporational, surface radar, and the ADS Bravo part. Currently, the modern concept provides for and for you to know, SURF ADS Bravo utilization. There is a movement, Surface Awareness Initiative is doing this, and they have approved the concept of aprons, ACE-MIX of air traffic control without the surface radar, which was the biggest cost. Naturally, for airports, you're talking about multilateralization, ADS Bravo. Who must make the decision to adopt the CDM operation concept in an airport, and based on which criteria? The CDM implementation, the concept, CDM concept, will always be regional, national. This region wants to introduce the CDM concept, meaning the flights within this region will follow the principles of a CDM operation, and it makes no sense to do it until you reach a moment where the demand reaches the capacity. Why? Because you would be introducing restrictions and you would be interfering in the flight intention of the airlines. Why would you do that if you have not reached the capacity, maximum capacity? So the decision must be common to all, mainly airlines and air control traffic. And this decision will happen as per the balance of the capacity and the demand. And in some schedules, in some hours, obviously, this doesn't happen every day at all times. But at some moments, the demand surpasses the capacity. So that's where the airspace manager should consider the introduction of the CDM operation to adjust the demand to the operational capacity, maximum capacity. Another question, how can we integrate the platform management with the air traffic control service? This integration is natural, and when we have surveillance sensors, for example, in the case of Rio de Janeiro today, We have a multilateralization platform. This feeds the control tower and it feeds the airport, and it can feed the airlines also and the ground handlers also. I can give you just this key point. How is it possible for passengers at one airport to have access to internet, to go into any web page of their interest, and the people who operate the airport have no access to the information of the position of the aircraft that are automatically triggering that information? It's contradictory. The people who operate the airport, air traffic controller, airport, airlines, ground handlers, they have the aircraft there throwing out information related to surveillance, and we have no stations to receive that information and deliver it to the users. The integration is natural. The sensor network feeds all providers, air traffic control, airport, airlines, and each uses the app they wish, the application to process the information in order to improve their operation. Two more questions. Three. Which are the main differences between ACDM and SCDM, and which do you think is closest to or more adapted, more fit for Latin America? There are many differences. I can summarize by saying the following. Surface CDM of FAA recognizes that the introduction of the CDM concept in an airport changes the life of the stakeholders, airlines, and ATC. The pilot would reach the aircraft whenever and would ask for the pushback. But when the CDM is implemented, the airline has to say the time they will be requesting the pushback at, and they will receive a window of 10 minutes, which is hard to comply with. Very tough if the airport does not offer you predictability. So recognizing that the main actors are the airlines and ATC, the surface CDM has these two main actors are protagonists. The airport can participate. How? By offering mechanisms to increase predictability, efficiency, and safety. The airport CDM, when it created the concept of the assist, it brought the airport to a protagonist position into a database where all the operators of the airport will be feeding information. And my recommendation is the following. There is no ideal model. And what FAA did in doing a benchmarking, learning about ACDM in Europe and adapting it to their needs is what the Latin American region should do, and each region should do. Understanding that before anything else, the concept of CDM operation as a network, as a region, as a nation, and if that makes sense, implementing the CDM at a network level, and when time comes to implement it in an airport, to adapt the different concepts that may exist in a surface CDM, ACDM, to adapt to the operational needs and requirements. We must take into account that CDM is not a project, it is a process. Project is something you implement a software ready to go, that's it. But process is a change in mentality. If you do not understand that CDM changes the priority of punctuality to efficiency of fuel consumption, we must understand that the fuel efficiency takes over the punctuality. It's a process. We have to understand what a CDM operation is, implementing it at a global level, and then eventually getting to the need to do it at the airport. It may happen that with a ground delay program, I have a couple of delayed flights that do not generate any surface congestion, and I can continue on with the first come, first served, with the exception of some flights that will be restricted, and which will wait 30, 40 minutes to depart. Again, none of them are in airport operations manual to be adapted and imported for one airport specifically. Two last questions. How is the implementation of the documents 9971 going and 99750 in Central America? Central America and Latin America in general, they would go in the same bucket. And I think we're going through a very sensitive process for the last 5 years. My position is against this. We have not understood or accepted the CDM operation concept. We do not have a regional flow management system. Cadena is an interesting mechanism to share information. We all know that Cadena is not a flow control system, and there is no ground delay program implemented ever in the region of Latin America or Central America that I know of. So no pathway to CDM that does not start through a process to understand 9971 and the requirements of GAM that make sense, then you should not go on that pathway. And I think that there's a lot of advertisement to implement that ACDM, airport ACDM, as if it were an airport project that where you buy a software, you implement the software. No, very clear question. What does an IT person understand about airport flow management? Nothing. There is a very serious issue there, and we have to rethink it, and let's try to increase the capacity of the airports. Typically, in Latin America, we operate blindly without surveillance with a flight controller who's responsible for the management of the apron. And this means low predictability, low efficiency. That's where we have to start. It makes no sense to think about CDM, and it makes no sense to think about interfering with the flight intentions of the airlines if we have not done the homework to increase the capacity of the airport. Very well. One in English. It says, something key there, and I will mention a problem that occurred in Bogota. When they tried to implement a ground delay program in Bogota, I mean, there are flights that are delayed every day. And when that happens, the problem we have is that even if nothing happens, no airport being closed or any bad conditions, when you implement a ground delayed program, the flight being delayed every day, it means that the planning of this flight is wrong. It's planned for a time where there is no space. So it's like a short circuit, the whole day gets short circuited because there is something wrong from the moment of installation. The solution is not to eliminate the short circuit, but to identify the problem, where the problem is. Question: if an airline wants to have a flight leaving at 8 and it's being delayed every day, or maybe one that will leave at 9, but it's on time every day, what does it want? So the parking position is related with the measurement of the capacity. If I have no surveillance tools that can measure, the efficiency under which I am using each position in the apron, it'll be very difficult to have this precision of the using the parking. That's why I was saying surveillance is not just monitoring the position, but it's all the measurements and calculations that are done automatically because they're identifying the time that each resource of the airport is being used, each roadway, taxiway, and parking position, etc. Perfect. Thank you. We have reached the end time. We don't want to take more time, not from Sergio, not from the participants. Sergio, thank you for sharing this information with us today. And all participants, thank you for accompanying us today. And if you have any more questions, please send them to this email, info@aci-lac.aero, and we will soon be sharing the responses that Sergio sends. So have a great day and a great weekend. Thank you. Thank you, everybody. Bye bye.